Hello again. In this video we are going to look at security regarding the BACnet web services. The BACnet web services use the HTTP REST module, and security is provided by TLS and a restricted subset of the OAuth 2 standard. We also use digitally signed JSON web tokens as access tokens. The Dingo stack, where the BACnet web services are implemented, contains an internal OAuth 2 authorization server. The authorization flows that are supported by the server are resource owner password credentials grant and the client credentials grant. The resources that the BACnet web services give access to are provided by the resource server. The client that we are using to communicate with the BACnet web services is the Dingo Manager. It uses the authorization flow called Resource Owner Password Credentials Grant. Let us have a closer look at how this flow works. We have a user. He is the resource owner and is capable of granting access to his protected resources, which in this case are on the Dingo device. During the security configuration, he will assign a username and password to the Dingo stack to protect his resources. The password credentials can be used directly as an authorization grant to obtain an access token that is used to request the protected resources. A client can be used to make the protected resource requests on behalf of the end user. He does this by giving the client the password credentials. Needless to say, there must exist a high degree of trust between the end user and client when this is done. The client in this case is the Dingo Manager. The Dingo Manager can now request an access token from the Dingo stack's internal authorization server by providing the password credentials. The internal authorization server will authenticate the password credentials and, if valid, issue an access token. The access token will have a limited lifetime and will be digitally signed to prevent tampering. The Dingo Manager can now request protected resources like BACnet objects, configuration setups, etc. by providing the access token. The Dingo stack will validate the access token and, if valid, return the requested resource. Now let us take a Dingo device that is not yet security configured. In this condition, the device is generally not suitable for deployment into the field. When doing the security configuration, TLS and OAuth security is not available and only clear text HTTP is used. Therefore, this configuration must be done on a trusted network. We log into the GoIoT cloud system and connect to the Dingo device via the Dingo Manager. We go to the network setup and make sure that the HTTPS is enabled under the HTTP setup. We then go under SSL certificate management and download the CA certificate. The CA certificate is used by the client to trust the HTTPS communication that is going to take place between the client and the Dingo device. The Dingo Manager runs in a browser, so we need to install the CA certificate into the browser's trusted certificate repositories. We have already done this, so there is no need to do it again. We then go to the Security tab. Here we make sure that the internal authorization server is enabled. I also specify that the lifetime of the access tokens that are going to be generated should be 15 minutes and save the changes. I am the resource owner, so here I specify a username and password. When I save the changes, the boxes become empty. This is because the username and password can never be retrieved again. We can, however, override by setting a new username and password. If we were using the client credentials grant, we would also specify a client ID and secret. Next, we generate a new private key. This private key can never be retrieved and is used to digitally sign the access tokens when they are generated. We also specify a unique device identifier that will be included in the access token, so that it is possible to see to whom the access token was generated for. We then reboot the device to activate the HTTPS server. When the device is rebooted, we change the connection settings for the Ting device and use the HTTPS port and enter the username and password. We can now connect again, and we see here that we have an access token with a limited lifetime. If everything works as it should, then we can go to the network setup and disable the HTTP server. The web services are now secure, running under HTTPS. Now let us use Node-RED to try and read a temperature value from a temperature sensor using the secured BACnet web services. I start by adding an inject node and add a HTTP request node with an HTTPS URL. We enable the secure connection and use the downloaded CA certificate to make sure that Node-RED trusts our BACnet web services. I then add a debug node so that we can see the result. We see that the BACnet web services are responding by saying that authorization is required to access this resource. So let us do this differently by requesting an access token first. We use a function that will define the elements of a HTTP request. The payload will specify that we are using the password credentials grant, and we provide the username and password. The URL will point to a place within the BACnet web services that is listening for access token requests. This function is then connected to an HTTP request that will use the post method and enable the secure connection. We then add a new function that will parse the response and find the access token. The access token is then stored in a global variable. We add a debug node and we see that we are receiving a long string which is actually the access token. We then add a new function that will use the access token to request the temperature value again. This time, the access token is added into the header of the request. We connect the function to an HTTP request where secure connection is enabled. We connect the request to a debug node and now we see that we are able to retrieve the temperature value. The communication between Node-RED and the Dingo device is over HTTPS. All the sensitive information, that is to say, the username, password, and access token, are placed in the body or header of the HTTP request. This means that these parts are encrypted when the communication is over HTTPS. Let us look at some best practices regarding web service security. HTTPS means that all communications between a client and the Dingo stack is encrypted. This will prevent intruders from listening or tampering with the communication. Our security measures use TLS. While HTTPS means that all communication between a client and the Dingo stack is encrypted, the URLs themselves are not encrypted. Therefore, sensitive information should never be added to the URLs in any form or manner. Any sensitive information in our communication is stored in the encrypted body or headers. An access token must be prevented from being modified because it contains information like its lifetime. We use a digitally signed JSON web token that a resource server can validate on its own. This prevents tampering and protects the token's integrity. So that is it. We have looked at how the BACnet web services use TLS, OAuth 2 and JSON web tokens to enforce its security. We have seen how we configure the security of the BACnet web services in the Dingo Manager, and we have seen how to request access tokens and use them in Node-RED. I hope you learned something from this video, and goodbye for now.